Welcome to today's class. Okay, in the second day of this chapter, that is matter around us. Before, we already discussed some parts of this chapter, and today we are going to discuss about the solution. Okay, so we are going to discuss about the solution. Okay, and also its type of the solution. Okay, some of you are not keeping mute. Okay, mute yourself, please. Okay, solution. Okay, it is it is a mixture of a solution is a mixture of solutes and solvents. Okay, very simply we can say a solution, okay, or it is a mixture of the solute, okay, and the solvent. Okay, there will come the question then what is solution or okay, solute and the solvent, okay, with mix in any composition or in any amount, okay. In any amount, that's better, make it so, simple. Okay, so this one. So any two types of the solutions they can mix. Okay, let's say we mix, let's say this one, the alcohol and the water they mix. Okay, it doesn't mean that they should have this much proportion. It's not like that. Okay, in any amount they can mix. Okay, and they will make the solutions. Okay, and here it comes the term that is a solute and a solvent. Then what are solutes and solvents? Okay, so the first point that is the solute. Okay, so solute is nothing that is the smaller quantity. Okay, the smaller quantity okay, or the smaller quantity present in the, just make it simple. Okay, the smaller quantity present in the solution. Okay, एक solution में present होने वाला जो component which are smaller in quantity. Okay, so that we call as solute. The smaller quantity present in air or present in the solution. Okay, is called solute. Okay, along with the example here will come. Okay, and another one is what? Solvent. Okay, so here will come the larger quantity. Okay, the larger quantity present in the solution. Okay, it's called, what is that? Solvent. Okay, it's called solvent. Okay, so this point we have to know. Okay, say for example here you make tea. Okay, so here when you make tea, here just say we take the components, maybe who is opening now. Now I told you to mute yourself now. Why I mute all also and Akil, just mute yourself. Okay, and some others are also not mute. Okay, the larger quantity present in the solution is called solvent. So I told you here two. Okay, it is a mixture of the solute and solvent. Solute may be of the more than two components. Okay, may be present there. Okay, so here we make the tea. Here what happened? Here in the tea we add the sugar plus. There we add the milk. Okay. Okay, so here sugar plus milk. Okay, plus what we put here water. Okay, we put here water. Okay, and here it will form together it will make the tea. Okay, so here the sugar and milk and water. What will form here? This sugar and milk and water. Which quantity will be more? The water quantity is more while making tea and all, right? So this water will be the solvent. Okay, the quantity of the water is more, so this will be called as the what is called the solvent. And this milk and the sugar, they are putting there in while making the tea in a small quantity only, so they are called as the just say solutes. Okay, so this is a simple example, and we can make the solution, that is the sugar solution and the salt solution. Okay, so I think you finished. Another example is that here we put the sugar. We put the sugar in water. Okay, sugar in water we add, then what it will form? It will form sugar solution, isn't it? Sugar solution, or if it is salt, then it will form the salt solution. And this sugar, it is added in the small quantity, so it will be the solute. And this water is added in the larger quantity, right? So it will be the solvent. Okay, so just keep in mind that the smaller quantity will be the solute, the larger quantity will be the solvent. Okay, and this is what? This is the solution that is formed. Okay, this is called the solution. Okay, so, and from here we already come to know that solutions contain two kinds of the substance named as solute and solvent. Okay, solute and the solvent are present in a solution. Okay, so that's point. Yeah, and now we are going to come about the types of the solutions we can discuss. Types of the solution. After that, we will discuss about there is the concentration. Okay, that means that the power also we can say. Okay, how strong the solution is. Suppose in जो चाय पीते समय कितना मीठा है, it depends, right? Okay, if you put the more sugar, ज़्यादा sugar डालेगा तो ज़्यादा मीठा होगा. Okay, and if we put the less amount of the sugar, then उसका कम ही मीठा होगा, isn't it? So that means that how much, okay, how sweet the what I call the your tea is, it depends on the amount of the sugar. Okay, so according to that one here, we will call it as a concentration. How much is the concentration of the sugar in the solution? Nah? So like that we'll discuss, that will come afterwards. Okay, so and now we'll discuss the what I call that is the type of solution, and before this one we can discuss a topic called as the Tyndall effect. So last time, if in the types of the mixture in the homogeneous and in the heterogeneous, I already given you there, that is the Tyndall effect. Some are called Tyndall effect, some are not, right? So, but what actually the Tyndall effect is, let us learn. Tyndall effect. Okay, so it is a simple phenomenon only. Okay, the scattering of the scattering of the light by the particles of the matter. Okay, the scattering of the light by the particles of the matter and make it visible the parts of light. Okay, part of the light. Okay, so the scattering of the light by the particles of the matter and make it visible the part of the light is called Tyndall effect. Okay, so this is the Tyndall effect. Examples will be there. Okay, in the dark room, in the dark, dusty, I will say dusty. Okay, if it is not dusty, you will not see. Okay, in the dark, dusty room. Okay, when we on when we on the no problem. When we on torch light, the part of the light is visible. When we on the torch light, the part of the light is visible in the dark room, but if the room is dusty, so at that time only we will be able to see the part of light. But if it is not dusty, then you will not see. So you may see there, even we can give in the forest also, when you wake up early in the morning, or you say if you go in the forest and all, so when the sunlight comes and passing through the all these kind of the trees, the light, the part of the light is visible. Or just simply when our room, suppose your room, in the room, some of the portion in the tina is have the hole, some hole, then when the sunlight comes there and it falls inside your home, then at that time also the part of the light is visible if your room is dusty. So how it is possible? Because the part of the light is blocked by the particles. When your room is dusty, many particles like a dust particle is flying here, right? So in that time when you on the torch, then the part of the light, you will find there the part of the light. But now itself you cannot see the light. Do you think that light, can you see the light? We cannot, we cannot see the light, but the part of the light is visible when the particles block it. जब particles से block करते समय part of the light को दिखाई देता है. And that property is called as the Tyndall effect, the scattering of the light by the particles of the matter and make it just change it please. Make it visible. Make it visible the part of the light. Is called Tyndall effect. It is not easy. Yes, it's only. Make it visible the part of the light. So this is a very simple examples of this one. In the dark dusty room, when we torch, when we on the torch light, the part of the light is visible. So this is the Tyndall effect. And here in the types of the solution, we are going to discuss, we are going to come as their property. That's why only I am giving here. So let us start the types of the solution. Now we'll come to the types of the solution. This type of the solution is according to the amounts of the what we call the size of the solute particle. Types of solution according to the size of the solute. According to the size of the solute, we are dividing. This one. Number first one, we can match this as a table also. But that you write in your copy when I give all. As a difference. So this is the this is chemistry class 9, day 2 class only. So number first one is the true solution. True solution. What are true solutions? That is the question. Those those homogeneous, solutions are mixture only. Okay, keep in mind, they are not a compound or they are not a pure substance. They are a mixture only. Okay, those homogeneous mixture in which the size of the solute particles is less than 10 to power minus 9. It will be the 10 to power minus 9. Just see, what is that? It is in terms of centimeter or a meter. In terms of meter only. Yeah, in terms of meter. Okay, so less than 10 to power minus 9 meter. Okay, those homogeneous mixture in which the size of the solute particle is less than 10 to power 9 meters. Okay. Yeah. Okay, it's called the true solution. Okay, I don't write it, it's called and all. Okay, so you must keep in mind that if the size of the solute particle is less than 10 to power minus 9, then that kind of solution will call as the true solution. This point. Okay, for example, here examples of the true solution is that here we can write the solutions containing the alcohol plus water. Okay, alcohol plus water. Okay, so that's one. And say sugar solution. Okay, sugar ka solution, salt solution. Okay, etc. Okay, so this is types of the solution in which the size you cannot see by the naked eye. Okay, so now comes the properties. Okay, properties of true solutions. Okay, properties of the true solution. Okay, so here we have to know about this one. What are the properties of the true solutions? Number first point is that they are what is that? Homogeneous. They are homogeneous mixture. Okay, so true solutions, they are a homogeneous mixture only. Okay, so this point you have to know. Okay, and number two, okay, the particles cannot be seen by naked eyes. Okay, by your naked eyes here we cannot see. Okay, so this particle also, yeah. Otherwise, surely I will pick out from the group here. Okay, so the particles cannot be seen by the naked eyes. Okay, so we are together only, and many students are here together only. So you have to think for others also. Okay, so I don't need to explain about all these things. You already know how I used to explain in the class and all. Okay, so don't let me to speak all these things. Okay, if I speak here, then surely it will come in the YouTube also. Okay, and to whom I speak also it will come. Okay, so particles cannot be seen by naked eyes. Okay, the particle size. Okay, the particle size is less than 10 to the power minus 9 meter. Okay, the particle size is less than 10 to the power minus 9 meter. Okay, so this point we have to know. Okay, some more points are here. I think you finished these portions, right? So I'll wrap it now. Okay, in the number 4. Okay, the particles cannot be seen by naked eyes. We already given, right? So here it comes. The particle cannot be filtered. Okay, particles cannot be filtered. Okay, we cannot separate the particles very easily here. Okay, particle cannot be filtered. Okay, by ordinary or just easy method. Okay, or नहीं तो just simply we write that particle cannot be filtered by this paper, filter paper. Okay, particles cannot be filtered by filter paper. Okay, and even if it is very small and cannot be filtered, then what may happen again? So you have to know that here the particles do not settle down. Okay, the particles do not settle down. Okay, the particles do not settle down when kept undisturbed. Okay, if we keep it without disturbing the solution, okay, 1 night, 2 night, or 3 night, whatever. Okay, so if you put like that, but still the particles will not settle down here. Okay, so number 6 point, they do not cause Tyndall effect. Okay, so this solution, that is a true solution, do not cause Tyndall effect. Why? You know, because this Tyndall effect, the particle size is small enough to scatter the part of the light. Yes. Who is that? Kept undisturbed. UNDISTURB. Okay. The particles do not settle down when kept undisturbed. DISTURB. Okay. Yeah, undisturbed only. Okay. So the particle size is very small. Okay, very small. Even it can't scatter the part of the light. That's why they do not cause Tyndall effect. Okay, so it can come in terms of homogeneous also. We already know that true solutions are homogeneous. In the exam, it can come questions like that. Why true solution? Okay, why true solution does not cause Tyndall effect, or not? Why homogeneous mixture do not cause Tyndall effect? Please mute yourself. Mute yourself first. Okay, why the true solution do not cause Tyndall effect, or why this homogeneous mixture do not cause Tyndall effect? They can come by this way also. Okay, but you have to know that homogeneous or true solution both are same only. So answer may be like this. Okay, the particle size of the homogeneous or a true solution is small enough to scatter the part of the light. So the Tyndall effect do not occur. Okay. Mute yourself. Mute yourself. Mute fast. Okay. So this is the question. Okay. So let us write down that one also in relations with that one. Okay. So up to here is the what we can write for about the current knot is admitting now. Okay. So this is about the properties of the Tyndall effect. Okay. Okay. So next is the what? I will write one question here. Okay. Why true solution or yes say homogeneous okay, homogeneous mixture do not cause Tyndall effect. Okay, why true solution or is it the homogeneous mixture do not cause Tyndall effect? This is the question. Okay, here comes the answer. I'll make it short. Okay, it is because the size, okay, or is it the particle size, okay, the particle size, okay, of the, it is because the particle size of the true solution, or is it the homogeneous mixture, okay, it is because the particle size of the true solution is small enough to scatter the part of the light. Okay, small enough to scatter the part of the light. Okay, so just up to here enough only. Okay, so it is because the particle size of the true solution is small enough to scatter the part of the light. Okay, that means very small to scatter the part of the light. That's why here Tyndall effect do not occur. Okay, Tyndall effect do not occur because of this reasons. Yeah, so this is all about the Tyndall effect is not occur in the true solutions. Okay, so this point we have to know. Yeah, again now here we are going to come the next point, that is the next type of the solution, that is we can discuss the suspension first. Okay, so you note down, and this current knot, why you are late, next time I will not allow to enter here in the class. Okay, so let me take attendance once now. Okay, yes, but this part, so I think you finished. Okay, so here in the second type here, what we'll discuss? We'll discuss the suspension. Okay, first one is true solution, next is called as the suspension. Okay, so here in the suspension it will come. Those, you must keep in mind, suspension are a heterogeneous mixture. Okay, those heterogeneous, those heterogeneous mixture in which the particle size, in which the particle size is more than 10 to power minus 7 meter. Okay, in which the particle size is more than 10 to power minus 7 meter. Okay, are called, just simply we can complete here. Okay, those heterogeneous mixture in which the particle size is more than 10 to power minus 7 meter are called suspension. Okay, okay, so welcome back. Yeah, so now here comes to this one, that is the suspension. Okay, so here in the suspension, those heterogeneous mixture, okay, those heterogeneous mixture in which the particle size is more than 10 to the power minus 7, okay, are called as the suspension. Okay, so suspensions, for example, we can say they will have the very larger particles and all. Okay, so here the muddy water, okay, so those water which contains, okay, so that is which is mixed with mud and all. Okay, so muddy water we can say. Okay, and also you say in terms of the chemicals, just say the chalk. Okay, that is the calcium carbonate. Okay, calcium carbonate. Okay, calcium carbonate and water. Okay, calcium carbonate and water. Okay, so that is the mixture. Just like a chalk. The chalk को हम लोग क्या पाउडर बनाकर जो पानी में डालेगा तो that will be okay. Or also yes, we can say the tuna. Okay, that is the calcium oxide when it's mixed with the water. Okay, so when we rotate and turn, it will be milky in color, and afterwards it will change. Okay, so it will settle down and all. Okay, some example we can give. Okay, they will be in the larger in size. Okay, so now comes the properties. Okay, so here comes the properties of, sorry, yeah, calcium carbonate means इसका formula है CaCO3. Calcium carbonate means that is present in the limestone. Limestone or also हम लोग का chalk that used in our school. It contains the calcium carbonate. Its formula is CaCO3. Okay, so that's fine. Yeah, properties of suspension. Okay, so here comes the properties of suspension. Number 1 point here, Niti Sarkar, just mute. Okay, so number first point is that they are heterogeneous mixture. Okay, they are heterogeneous mixture. Number first point. Okay, number 2 point. The particle, okay, the particle size is more than how much? 10 to the power minus 7 meter. Okay, 10 to the power minus 7 meter. Okay, so this point. And in the number 3, anyone is joining now? Just let me check once. Okay, yeah, no one. Only 20 of you now. Before more number. Okay, let me see. Okay, the particle size is more than 10 to the power minus 7 meter. Okay, so and the number 3rd point here we can say the particles can be seen by naked eye. Okay, the particles can be seen by naked eye. Number 4th point, the particles settle down when kept undisturbed. Okay, when we give undisturbed, okay, the particles will settle down. Okay, and in the number 5 point, okay, the particles settle down when kept undisturbed. And the number 5 point here, they cause Tyndall effect. Okay, they will cause the Tyndall effect. Okay, and what else we have? They are heterogeneous mixture. The particle size is more than 10 to the power minus 7 meter. Particles cannot be seen by naked eyes. Particles settle down when kept undisturbed. They cause Tyndall effect. Okay, and the number 6 point, what we can write, the particle can be separated. Okay, can be separate. Okay, can be separated by filter paper. Okay, can be separated by filter paper, or you say very simply we can say by ordinary method. Okay, by the simple method we can separate the what I call the particles. Okay, so here muddy water, chalk and water and all. Okay, we can give this one. Okay. Yeah. Okay, now this is about the suspension, and you must keep in mind that there may be the questions come. Give the difference between suspensions and the true solution. Okay, give the difference between suspension and true solutions can come. Okay, so for that one, what you have to do, you must write down by making the table. Okay, so by making the table, you have to write down. Okay, suspension I remove here, and I will give you the homework now for these two. Okay, yes, yes, tell me. Unstable. Okay, unstable means that the particles. Okay, you mean what called suspensions are unstable. Unstable means that here see the particles of the this one suspension, they will, when they mix they will move here and there. Okay, they will move here and there, and when keep undisturbed, they will settle down. Okay, when they are mixed at that time, the particles will be, they will not mix up with the water. Okay, they will be present in the water, and they will move floating here and there. Okay, so that's only. Okay, and when yes, what? Oh, okay, fine. Butter, you understand? Who is asking? Now understand? Okay, so particles are unstable means that the particles, they are moving here and there. Okay, when we mix. Okay, but if we keep for some more time, then they will settle down, and we will find in the bottom of the what I call the beaker, or is the place where they are keeping. So that's why. Okay, so this is the home task. Okay, homework. Keep the home task means you have to write down in your copy. Afterwards, you give the space. Keep the difference between. Okay, or give the differences between. Yeah, property only you have to write. Smithy, give the differences between what is that true solution. Okay, give the differences between true solutions and suspension. Okay, by giving 3 marks. 3 marks, that means you have to write 6 points. Okay, so this 6 points you have to write down. Okay, give the differences between true solutions and suspensions. Okay, so you make a table. You make a table like this. Here is the true solution. This is the suspensions and all like that. Okay, so you make it properly. Okay, in your copy. Okay, so we'll proceed to the next type of the solution, that is called as the colloidal solution. Okay, so it comes. Yeah, only that homework you can upload. Okay, so I will give you one more homework also. Okay, you have to write down. Why? In the WhatsApp group, what? Oh, no need. You have your number, and in your number you have your own photo. That will come in the WhatsApp group. No need for the WhatsApp group, is only just to get information. About all those. You will upload in the WhatsApp, not in the WhatsApp group, and you should be in this one, what I call our JNK Public School app. Okay, so this is the homework. Yes, Dakpe. or is there in the, there will be, just try, yes sir, no problem, you can get. Okay, so that one no problem, I will explain you afterward. Okay, so just concentrate now. Okay, so for that one don't worry. Okay, so now third types of the our solution is, what is that? Colloidal. Okay, true solution, suspension and colloidal. Okay, colloidal solution we can say, or just simply we can call it as a colloid or a colloidal. Okay, sometimes you will get in the name of the colloid, COLLOID, colloid. Okay, or I just say colloidal solution. Okay, this is also okay heterogeneous mixture only. Okay, those heterogeneous mixture, okay, those heterogeneous mixture in which the particles, okay, in which the particle size is in between 10 to power minus 9 meter to 10 to power minus 7 मीटर. ओके, ये हेटेरोजेनियस मिक्सचर है और उसका पार्टिकल साइज है 10 to power minus 9 और 10 to power minus 7 मीटर का बीच में है. ओके, सो इन बिटवीन 10 to power minus 9 मीटर to 10 to power minus 7 मीटर. ओके, okay, are called, okay, that is the colloidal. Are called colloidal solution. Okay, so this point you have to know. Yeah, and here will come the example. Okay, examples of the colloidal solution is say the fog. Okay, so fog, and you know, milk. Milk is also a colloidal solution. Okay, blood is also a colloidal solution, and soap solution. Okay, so you know the milk, the white color you see. Okay, you observe there in the milk contain some amount, some kinds of the protein. Okay, so the proteins along with the water only. Okay, it is a mixture of the proteins along with the water. Okay, so that is also a solution. You know, one animal is there. Okay, I think I already told you in the class also, but you know, one animal is there. Just I have to check that name. Okay, one animal is there. I think the sheep. Oh no, I forgot. It is a swan or something like that. Okay, one animal is there which can drink only the protein part. That is in the milk, white colored. White color only they can drink, okay, and just leaving behind the water. Okay, one animal is there who can do that one. Okay, let me check. Okay, yes, I got confused. Yeah, I think so, swan, but I'm not. Just let me check. Okay, maybe. Oh, is it? Oh, that then it should be swan. Yes. Okay, if I give you, then surely will be. Okay, swan. Yeah. So who can drink, take out only the milk, okay, white color part, and just remain only the water part. Okay, yeah, that's fine. Look here, milk, blood, soap solution, sabun ka solution. Okay, so they all of etc. You're right, no problem. They are all what are called colloidal solution. Okay, so colloidal solutions. Okay, now will come the properties of the colloidal solution. Now let us go for the properties. Daddy, just mute yourself. Properties of colloidal solution. Okay, so what are the properties of the colloidal solution? Okay, so you have to write here, they are heterogeneous. Okay, they are heterogeneous mixture. Okay, so this is the first one, and number two is that the particle size okay, or just say simply the particles cannot be seen by naked eyes. Okay, by our naked eyes, the particles cannot be seen. Okay, in this colloidal. Okay, and yeah, homework. I think you already write down. Yeah. Yeah, properties. Okay, now in the third point. The particle size, okay? The particle size is in between 10 to power minus 9 से लेकर 10 to power minus 7 meter तक, okay? The particle size is in between 10 to power minus 9 meter to 10 to power minus 7 meter, all right? And in the fourth point, what we can write? The particles cannot be separated. Okay, particles cannot be separated by filter paper. Okay, the particles cannot be separated by filter paper. Okay, we have all the filter paper, we cannot separate. And the 5, they cause Tyndall effect. Okay, so this colloidal will also cause Tyndall effect. And 5 points, what we can write before what we write, they are heterogeneous. Yes. But the particle size is big enough. The particle size of the colloidal is big enough. It is not about the हम जो दिखाई देता है दिखाई देगा तो Tyndall effect होगा नहीं होगा तो ये नहीं होगा इसके बात नहीं है. Okay. So Tyndall effect it depends on the particle का size में. If the particle size is more than 10 to power minus 7, okay. 10 to power yes minus 7 and it is in between ये दोनों का बीच में भी होने से भी okay. So the particles are big enough to scatter the part of the light. Part of the light जो है ना scatter कर सकते हैं मगर जो particle का size जो है 10 to power minus 9 से छोटा हो जाएगा तो if it is less than the 10 to power minus 9 then it will not cause the Tyndall effect. Okay, it will not cause the Tyndall effect. This point you have to keep in mind. Okay, it depends on the particle size. It's not about जो हम लोग दिखाई देता है या नहीं देता है. It doesn't matter. Okay, so that's point. So understand, Smriti? Okay, so what is heterogeneous mixture? Particles cannot be seen by naked eyes. Particle size is in between. Particles cannot be separated by filter paper. They cause Tyndall effect. Okay, another one is that the particles do not settle down. Okay, the particles do not settle down when kept undisturbed. Okay, हम लोग डिस्टर्ब ना कर रखने से भी वो लोग सेटल डाउन नहीं होता है. ओके, तुम सोच रहा होगा मिल्क को 1-2 दिन रखेगा तो ये सॉलिड बनता है सर ये सस्पेंडेड होकर नीचे में बैठा है क्या बोलेगा सेटल डाउन हो रहे क्या बोलेगा नो. ओके, इट इज नॉट. Okay, that is due to the curding of the milk. जैसे कि milk जो है curd बना रही है. Okay, due to the fermentation or due to the actions of the yeast in the atmosphere in the environment, उसका वजह से ही वो लोग क्या ये दही बना रहे हैं ना. But it is not it's not about just settling down. Okay, not settle down. Okay, so just keep in mind that is the curding of the milk. Okay, so that's point only. Yeah. Yeah, this will be the number 6, right? Yeah. These are the properties of what? That is the what is it? Colloidal, right? So these are the properties of the colloidal solution. Okay. Yeah. And another homework. Okay. Another homework is that give the differences between. Okay. Number 1, I already given you another one, right? Battery is going down. The class will be over. Yes, now class is going to be over. No problem. Okay, so I'm going to write homework and finish. Okay. The difference between is that number 1 is that true solution and what is that? Colloidal. Okay, true solution and colloidal. And number 2 is again colloidal and the suspension. ओके हमने पूछा है इधर में डिफरेंस सेम प्रॉपर्टी को डिफरेंस है बोलकर तो मत लिखो. ओके डोंट गिव द एनी आंसर दैट दे आर सेम प्रॉपर्टी को डिफरेंस है बोलकर तो मत लिखो. ओके दैट विल बी रॉन्ग. आई वांट ओनली द डिफरेंस. एनी पॉइंट एटलीस्ट 2-3 points you have to write down. If you have the more point, no problem, you can write. But if have, okay, you must find out at least 3 points to निकालना पड़ेगा. More than 3, I accept, but less than 3, no. Okay, all these 2 questions. Okay, so that is for today's class, and thank you and all for the class and for joining the class.